This lesson is 3.5, Compound Interest Formula. What are the advantages of using the compound interest formula? How did the use of computers make it easier for banks to calculate compound interest for each account? Without the help of computers, how long do you think it would take you to calculate the compound interest for an account for a 5-year period? So here's our formula for compound interest. And again, this is something you're going to want to know. Excuse me. B is our ending balance. P is our principal, or our initial value, or our starting, what we started with. R is our annual interest rate in percent. N is the number of times a year that the interest is compounded. So use 3-4 for those numbers. And T is your time. So Jose opens a savings account with a principal of $1,300 that pays 5% interest compounded quarterly. What will his ending balance? Now notice, this one gives us a balance, not the amount of interest we're going to make. So we don't have to do an extra step. So what's our balance after 1 year? So this is our time. So B equals 1,300 times 1 plus our rate of 5% compounded quarterly. So how many quarters are in a dollar? How many quarters are in a year? So N is going to equal 4. Raised to the 4 times 1 year is 1. So go ahead, pause, and find that answer. And again, remember it's money. So 2 decimal places. So $1,366.23. So they made $66.23 in interest. But the question asked, what will his ending balance be? So be careful and make sure you're answering the questions that are asked. All right, next one. Rico deposits $800 at 3.87% interest compounded semi-annually. So that means N equals 2. What is his ending balance then? 10 years. So that's our T value. So B equals 800, 1 plus 3.87% divided by N equals 2, raised to the 2 times, now we're doing 10 years. Go ahead, pause, and get your answer. You should have $1,173.70. All right, example 3. Now you're going to deposit $2,500 for 5 years at 5% compounded daily. So daily is 365. Find the ending balance. So B equals 2,500, 1 plus 5% over N is 365, raised to the 365 times 5 years is your T. So go ahead, pause and find your balance, which should be $3,210.01. So it asks for the balance. Now, if you were going to find the interest is the difference between the principal and your balance. Okay? All right, exercise 4, example 4. Now Nancy deposits $1,200 into an account that pays 3% interest compounded monthly. So that compounded is very important on which equation you use. So monthly, N equals 12. What is her ending balance after 1 year? So that's your T. So B equals 1,200. 1 plus your rate, which is 3%, divided by the number of times it's compounded, 12, raised to the N, which is 12, times your time, which is 1. So go ahead and put that in your calculator. And again, remember it's money. So we got $1,236.50. So she made $36.50 in 1 year for interest. Now think about if we were using our simple interest like we were in last class. We would have to do that 12 times and keep finding the new principal, keep finding the new principal, and oh my goodness, way too much work or way a lot of work. I'm glad there's a simple formula for it. Okay, so go ahead and try your extend your understanding, and then continue the video to check your work. So you'll notice that I put in orange all of the given information, and I put in blue the start value or the principal, which I gave $1, and then our time, and I made it $1. So I could compare with the same principals and the same amount of time, which one had a better percentage. And we can see 3.2%. So compounded quarterly, because yes, it's less times, but it's a higher percentage. And that's opposed to a lower percentage and more times. But it didn't matter. Okay? This was a better deal or the best deal. All right, example number 5. Sharon deposits $8,000 in a 1-year CD at 3.2% interest compounded daily. What is Sharon's annual percentage yield to the nearest hundredth of a percent? So when we look to the right, we see the annual percentage yield, or APY, is a formula. And it's our compounded formula minus 1. And we learned up here that if we just take these pieces, we get this rate. So if we take our rate and subtract by 1, this is our annual percentage yield. All right, so we're going to plug in our APY equals 1 plus our rate, which is 3.2%, divided by daily, which is 365, raised to the 365, and then to go from this number, we have to take away 1 to just get the rate. Okay, so minus 1. So go ahead, pause, put that in the calculator, and find what the rate is. And we're going to the nearest hundredth. So we should get a decimal of 0.032516, blah, blah, blah. And because it says to the nearest hundredth, you want to go over 2 or multiply by 100. And to the hundredth would be 3.25%. Why don't you try the check for understanding, continue the video when you are ready to check your work, and then we will do the extend together. Alright, so hopefully you got 4.19%. The extend your understanding. Consider an amount X deposited into a CD at 2.4% interest compounded daily, and the same amount deposited into a CD at the same rate that compounds monthly. So we went from daily to monthly. Explain why, after 1 year, the balance on the CD that compounds daily is greater than the CD that compounded monthly. So why is daily greater than monthly? And we talked about it above in the extend your understanding. Because you have more compounds, you're earning money on your money. So because you're compounding it daily, every day the interest is added to your principal. And you just keep making more money. As opposed to monthly, you have to wait for a month, get your interest, then wait for another month, get your interest. So because you are compounding more frequently, your principal is going up more frequently. If you have any questions, please don't hesitate to ask. Good luck.